Hello and good day. This is the video presentation for our short paper, a latent model for ad hoc table retrieval for ECIR 2020. This is a joint work by myself, Ibrahim Bagheri, and my colleague Feras Al-Obidat. The paper focuses on the problem of ad hoc table retrieval, which aims to find a ranked list of tables given an input query. For instance, if you look at the table shown on the slide, the query is Singapore, and the idea is to find all related tables that somehow relate to Singapore. The task has close resemblance to the ad hoc document retrieval task, but there are also differences. For instance, the documents in ad hoc document retrieval provide sufficient context for ranking. They have continuity within sentences, but within tables you do not have continuity of content, and there is not sufficient context. Therefore, ranking is a bit harder. Existing methods for table retrieval are learn to rank based models based on manual features, or more recently, semantic similarity based models that connect query and document spaces. And here, documents are tables, obviously. In terms of performance, state of the art methods report very reasonable numbers. For instance, on NDCG at 20, L2R models report up to 0.6 performance. Semantic models such as SDR, which is maybe the state of the art right now, reach a performance up to 0.683 on a corpus with 1.6 million tables. So the problem that we address in this paper is that if you look at the baseline methods, existing methods, you will see that similar to ad hoc retrieval methods, these methods do not treat all of the queries equally. In other words, there are some queries that are addressed very well by these methods, but some queries actually suffer and do not have good performance. Therefore, the objective of this paper is to provide a method that improves the performance of the so-called hard queries or difficult queries. Empirically speaking, if you look at the queries that are addressed by each of these baseline methods, you would see that, let's say, if you take the bottom 20% of the queries based on average precision, you would see that the wiki table method does not have any queries within the 12 queries that are the bottom 20% of the queries that have at least one relevant table. In other words, these 12 queries, none of them return any relevant tables. For LTR method, there are 10 queries that don't return any relevant tables, and so on. STR method, which is a semantic-based method, has a better performance, but still there are 5 queries that have no relevant tables retrieved. So our hypothesis, based on empirically going through the queries, is that the bottom 20% of the queries based on average precision are those queries where there is little or no term overlap between the query and relevant tables. And comparatively speaking, that is why SDR model that is based on semantics actually performs better than L2R models that are based on manually defined term features. So because of that hypothesis and our observation, we learn latent representations for queries and tables, not based on exact terms within tables, but based on transitive relationship between tables and how terms co-occur in different tables. So our method is very simple. It uses a matrix factorization model where you have tables and terms, and these terms are distributed in different tables. Therefore, you can learn table and term representations. We add a regularization term to the matrix factorization process to ensure that the latent representations learned are biased towards the similarity of the baseline retrieval methods. In terms of experiments, we use a corpus released by Zhang and Balog. It has 1.6 million tables, and it comes with 60 queries and related relevance judgments. Um, for representing tables, we consider both keywords, which are the terms within the table, and entities. And the entities are those, because the tables are from Wikipedia, these entities are already identified. For the queries, we run these through TagMe to get the entities. We report our findings based on NDCG and ERR at 10 and 20. In terms of key findings, we find that the variation of our model that uses keywords is able to outperform the baselines in a statistically significant way. When we consider entity information, the performances are improved, but they're not always statistically significant. Um, and we find that the reason for this is that entity information within tables are sparse, and therefore a matrix factorization model does not perform well on sparse information. And we finally find that our model is very suitable for satisfying those queries where the tokens, either the words or the entities, do not appear um, within the relevant tables. So to give you some examples, here are some queries that were improved by our method. The green ones are those queries where the terms in the query only partially appeared in the relevant table, and the yellow rows are those where the term did not appear. The term in the query did not appear in the table. So as an example, take query 30, which is pain medication, for the baseline method wiki table. The relevant table with the title diseases and conditions is considered to be relevant for this query, but that table does not have either pain or medication included in it. However, because we learned the latent representations, we're able to rank it at rank 2, whereas the baseline method wiki table ranks it at rank 12. Thank you for your attention and for listening, and we would welcome any comments. Thank you very much.